Hello everyone, welcome to attend our class. Today we are going to study section 6.8, Arrangement and Constitution of Bolted Connections. In this lesson, we will study the arrangement and performance of bolted connection in section 6.8.1 and the failure modes of bolted connection in section 6.8.2. The bolt arrangement on the member should follow the principle of simple, tidy, and compact, and the connecting center should be consistent with the center of gravity of the section of the connected member. Parallel connection is a common arrangement mode, which is simple and neat. The size of the connecting plate is small, but it may weaken the section of the member greatly. The steel plate may be cut if the distance between the bolt center and the edge of the plate is too small. For tensile members, the bolt center distance should not be too small, otherwise the steel plate may be split on the net section failure. For compression members, the center distance of bolts along the direction of the acting force should not be too large, otherwise local buckling is possible to occur. If the distance between the bolt and the margin of plate is too large, then the steel plate cannot be closely jointed. Moisture is easy to enter the gap and cause corrosion, so the maximum allowable distance between the bolts is specified. In the construction process, in order to facilitate the rotation of the bolt latch, it is necessary to ensure a certain amount of workspace. Therefore, the minimum permissible distance between bolts is also specified for the convenience of construction. In addition to parallel joints, there is another common arrangement in engineering, which is called staggered arrangement. Compared with the parallel connection, the cross-section of the staggered arrangement is weakened less, but the bolt arrangement is not as compact as the parallel connection, and the size of the connecting plate is larger. In order to ensure the safety of connection, the center distance of bolts, the distance from the center of bolts in the direction of internal force to the edge of members, and the distance from the center of bolts in the direction of vertical internal force to the edge of members should meet the maximum and minimum permissible distance. Shear connection is one of the most commonly used forms of bolt connection. The study shows that when the external shear force is not large, the friction resistance between the components will firstly resist the external force, and as the external force increases and exceeds the friction force, the relative slip will occur between the components. Then the bolt and the whole wall contact. The bolt will be in shear and the whole wall will be compressed. The relation curve between the force and the relative displacement on the bolted connection can be divided into 4 stages: the elastic stage, the slip stage, and the bolt resisting stage and failure stage. The failure modes of ordinary bolts include when the diameter of the bolt is small and the plate is thick, the bolt may be cut off, as shown in figure A. When the diameter of the bolt is large and the plate is thin, the plate may be crushed down, as shown in figure B. When the net section area of the plate is weakened too much by the bolt holes, the plate may be split, as shown in figure C. When the end spacing of the bolt arrangement is too small, the plate within the end spacing range may be damaged by the punching shear, as shown in figure D. Bolt bending failure may also occur when the bolt length is large, as shown in figure E. That's all for this lesson. See you next time.